Okay, so last week, one of the things we did, this was our notes, and what this question was actually asking us was to take this original function and transform it using these transformations and state the transformation of key points. So we wrote it out in words, we made it in an ordered pair, and we did a little table of values there and did it all that way. And then I said, when we did this, that yes, if all I needed was the graph, I could have just looked at this and now I'm supposed to go to the left 3 and down 4, and I could have counted left 3, down 4, totally 100% fine. And all this stuff, other stuff isn't really necessary, but that's not the only way you're ever going to do it. That's why I wanted you to see how to kind of do everything. So then I had somebody ask me a question on the assignment, and they had obviously been paying attention. It was this one, and they had all the stuff written out. They had done basically what we did on the notes, and then they were kind of getting lost, not really lost in it. I mean, what they did was correct, but they were second-guessing themselves, I guess. But you don't have to do everything on all of these questions. Some of them are simple. Don't think because I mean, this could be a question on the AP exam. Just because it's on the AP exam doesn't mean that it's difficult. So don't overthink things. I know that's easier said than done. But when we're looking at this, they give us a graph and we have 4 to match it. And this is my transformations here. I can look at this and you can write it out if you want, and you could do the order pairs, you could do the actual t-tables, all that's fine. But I know that I'm going to go which direction? What does that mean? To the right 1 and up 2. So if I start here at this point and I go to the right 1 and up 2, that's this point right here, okay, which is at negative 3, 3. Not only do I have a point that's at negative 3, 3, it's this point that I moved, right? So when I start to look at these, I go to negative 3, 3. I have a point there, but it's not the correct point, so my answer is not A. I go over here, negative 3, 3, I don't even have a point. Here, negative 3, 3, I don't even have a point. Here, negative 3, 3, and it is the correct point. My answer is C. And then I didn't have to do all of the other stuff we did. Does that make sense to you? But depending on how they asked the question, maybe I needed to do some of the other stuff. We just kind of did it all on all of them to walk through it. Okay, but you don't always have to overdo things. All right, so I just wanted to make that little note here. All right, so here's where we are today. This is also going to go on page 42 because I think you have plenty of room for that. It'll just be one more piece of paper. All right, and one thing that I know I pointed out last week, and I'm going to say this again, pay attention to how things are labeled. This is the graph of F. It tells us that it is the graph of F. And then it's asking me to find the domain and range of F, which means I want the domain and range of the graph, not of something else. So again, make sure you're paying attention to what's what. So domain, those are my x's. Where does my domain start? Negative 5. And that is a point, not an arrow, right? So that's why it's not negative infinity. But it is closed, so I'm including it. Then I get to use all the x values until I get to 5. Right? So hopefully domain and range is fairly simple for you. Range, where does my range start? Negative 3. And that is a point on the graph, so it is closed. I get to use all my y values until I get to 3. And that is also closed. Okay. Everybody good with that? Easy enough? Okay. So then it tells me that I have g of x. So all that was f. Then this is g of x. And g of x is transforming f. So I want the domain and range of g this time. Now, I'm not going to write out all the words. I'm going to skip some of that. If it helps you to write out the words and then do the rest, you know, you do you when you need to do that stuff. But again, we don't always have to do all of it. But I am going to look at this as how the ordered pairs transform. Okay? So if I started with f, that's just my plain old xy. Then I look at these transformations. How many of the transformations here affect x? Just one. And this means I go which direction? To the right. So that means my x becomes x plus 1. Remember, x is a liar in function notation. When we take it out of function notation, we are revealing the truth. Okay? Then the other two, so the 2 and the 3 affect y. Well, f of something, that's just a y value anyway, so it's really 2 times y plus 3. That is your y value. Okay? Everybody good with that? All right, now, I am pretty confident that y'all know the difference between intervals and ordered pairs. However, that doesn't stop us from doing weird things sometimes. So when we are doing the domain, remember this is an x value, this is an x value, this is a y value, this is a y value, because that is range. And then these are xy, xy, right? This one was for f, and then this one would be for g. So when I go to find the domain of g, this is going to be 2 x values again. Well, for every x value, all I have to do is add 1. So negative 5 plus 1, negative 4. 5 plus 1, 6. That's my domain. For the range, each one of them I have to multiply by 2, then add 3. So negative 3 times 2 is negative 6, plus 3 is negative 3. And then 2 times 3 is 6, plus 3 is 9. Okay. And we did something similar to that with domain and range last week as well. We all good on all those? Yes? Yes, ma'am. Yes, 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 yes. Yes, all of these were all dealing with F and G. Yes. Yes, because otherwise I wouldn't, if I didn't have that, I wouldn't really be able to answer this question without some more information. But yes, they go together. We're talking about that same F. And because I know sometimes if it's going to be like on a worksheet or on a test or something, it should really say on here, like using F from example 1. Either that or it'll be like a number 1 and there's an A, B, and C, so you can definitely tell that they go together. So that's a good question. Thank you. All right, anything else? So all this whole front page is all with the same F and G. It's a very good question. All right, so then we have this point, 4, 2. And it's going to transform, so that's the point on F. And we want to transform to which point on G? So since I don't have a graph, and I'm not just thinking about my transformations, what's happening, I have this. This is F, this is G. And in this case, instead of x, x, and y, y, this is not an interval. This is an ordered pair. This is x, y. Might be helpful to label things like that so you don't go do something weird. Because when they're open intervals, they look like ordered pairs, okay? But my new one for G, I take the x value and add 1, so that's 5. I take the y value, multiply it by 2, and add 3, and I get 7. Okay? Okay, what questions you got? So we're kind of taking a little bit of everything we did last week. We did the domain and range, transform a point. I think it's easiest just to make your ordered pairs and then do your thing that way. Then we also had some where we substituted it in, right? G of 0, I don't need my ordered pairs or any of the rest of that. I have my equation right here. This equation right here is G, so I can just substitute in a 0. Say G of 0 is 2 times F of 0 minus 1 plus 3. All I did was literally substitute it into the equation they gave me. Then when I clean this up a little bit, I'm going to get 2 times F of negative 1 plus 3. Now I can't multiply the 2 times the negative 1 or anything like that because this right here, F of negative 1, represents a y value. How do I figure out what that y value is? Where do I look? The graph. So on the graph of F, because that's F of something, I'm looking at F, when F is negative 1, or I'm sorry, when X is negative 1, F is at 3. So this is really just 2 times 3 plus 3, which is 9. Okay. What questions do you have? All right, so then D says how many solutions, not necessarily what are they, but how many solutions does the equation g of x equals 0 have, and explain your reasoning. Now, sometimes explain your reasoning, your work is okay for that. There's going to be times where I ask you to explain your reasoning and it wouldn't necessarily be a free response question on the AP exam. When it is, that's when we get very specific about how we say it, because they're very specific about what they want. In this case, you wouldn't necessarily have to explain this one, and our work really is going to be kind of the explanation here. So g of x equals 0. I have an equation for g of x. That was 2 times f of x minus 1 plus 3, right? That's g of x. And I'm just going to set that equal to 0. I am then going to treat this like an equation. I've been solving equations forever. Not going to make up any math because this just represents some y value. I'm just going to treat that like one big variable. So I'm going to start by subtracting 3 from both sides. So I get 2 times f of x minus 1 equals negative 3. Then this is being multiplied. So I'm going to divide, and I'm going to get f of x minus 1 equals negative 3 halves. Okay. So it's not quite yet f of x equals negative 3 halves, but that would just mean all this transformation is to go left or right, yes? So I'm going to use this, since I don't have to actually find the exact solution, which you'll see I won't be able to because I'd have to be guessing at numbers, sort of. But I'm going to come up here. This represents some y value. When there's some y value that equals negative 3 halves, that's like negative 1.5. So negative 1.5 would be about right here. Okay. How many times does negative 1.5 intersect that function f? Once. Okay, and so my x value wouldn't be, so this is my y value. This wouldn't be my actual answer. I'd have to shift either to the left or the right, depending on that transformation down there. But either way, it's not asking me what it is, it's asking me how many. So how many times is g of x going to be 0? And it would just be once. So we can say g of x equals 0 exactly once. Because really we just move to the right one and get your answer, but it's only going to happen once. We're going to look at this a little bit differently on the back when we're going to actually find a value. We'll look at it again. Okay, we good? All right, so then it asks us when g of x is increasing. Now, I don't have a graph of g of x to look at. I don't want to have to graph the whole thing. But I have f of x, and I can see that f of x increases from here to here and from here to here. Would you agree with that? So when we transform it, if we think about what's actually happening with our transformations here, when we transform f, we move it to the right one, we stretch it vertically, and then move it up 3. Okay, so we move it to the right, and then we sort of stretch it and move it up. Does that change what pieces of the graph actually are increasing? It doesn't. It moves where they are and stretches them some, but the pieces are the same. Does that make sense to you? What would change my increasing pieces to decreasing? What kind of transformation? A reflection. If I reflected in the x-axis, then what's increasing would become decreasing and vice versa. Does that make sense? But I don't have any reflections, so I'm fine. All I have to worry about is where f is increasing, and then that can help me with g. So let's come down here. And I know it's asking for g, but you have to use f to figure this out. So I can say f is increasing on, all right, where does it start increasing? Negative 4, good. To what? Negative 1, good. And then from 1 to 4. Okay. So that's where f is increasing. Therefore, g is increasing on, all right. Now, yes, we have x and y values on our graph. We see where f is increasing. But what we write are intervals of the domain. These are all x values, right? All 4 of them are x values. So when I look at my transformations and I'm trying to figure out what those intervals are, all I'm looking at is the x part of that. So that means if f is increasing on these intervals, then I just take those intervals and add 1 to every single number. So I get -3 to 0 and 2 to 5, and I'm done. Okay? Yes, the y values change also, but that does not change the interval of what is increasing, because it stretches it this way. Okay? The width is the same, basically. Everybody okay with that? Good. All right, so flip it over. Okie dokie. So we have this graph that doesn't have a name. I don't know if it disappeared or if I forgot to put it, one of the two. But that's f. Example 3 says h of x is equal to this equation, or equal to that expression, and I want to find the domain and range of h. Is it asking me for the domain and range of the graph? No, because that is f. Now, do I need this to find this? Yes. So we'll write it down. It's the same as the one on the front. -5 to 5, and the range, -3 to 3. Okay. So then go ahead and see if you can write out your ordered pairs for this would be f, and then what would h look like in ordered pairs? Or an ordered pair. How many transformations affect x? 1, and this means I go in which direction? Left. So this actually becomes x minus 3, and then this would be -2y minus 1. Okay. Everybody good with that? Okay, now you write your domain and range for h. So remember here that this is x, this is y, so we don't do anything weird. So for my x's, I have to subtract 3 from both. For my y's, I have to multiply them by -2, then subtract 1. Do you agree with this one? Is it written correctly? Yes. Is this written correctly? No. Do I have the correct numbers? Yes. But since there was a reflection there, this needs to be written -7 to 5. You have to go least to greatest. Okay? I personally think the easiest way to do it is write them down just like I did, and then make sure you're going from least to greatest, and if not, you just flip them around. Okay? Everybody okay with that? We good? So don't mess that part up. All right, so because we did it this way and we really didn't talk about what the transformations are, let's do that real quick. This negative means I have a what? A reflection across which axis? X, okay? Then a vertical dilation, right? And then horizontal and vertical translations. So I'm looking for, it asks me when the graph of H, okay, the one I can't see, when is it concave up? Do you think I need to look for when F is concave up? No, because it's going to reflect, right? So if I want H to be concave up, that's when F is what? Concave down, exactly. And then the points of inflection aren't marked on here, so I'm going to mark it with X's, because sometimes when I try and make a point, my board doesn't like it. So those are going to be our points of inflection. So then what we're going to write here is that F is concave down on, where does it start to be concave down? -2, good, to what? 0, good. And then 3 to 5. Is that right? Make sure y'all agree with me. Make sure I'm right. 3 to 5. Yeah. All right, that's when F is concave down. Therefore, H is concave up on, and these are all x's, correct? And all I need to do for my x values is subtract 3. So this would be -5, -3, and 0, 2. Okay. What questions you got? Yes, ma'am. Okay, when you do concavity and increasing and decreasing, always open, always open. These are closed because it's domain and we're including those. If you had it closed and they were increasing and decreasing, we could argue about it, you'd be fine. I wouldn't count it wrong. Technically, it's not wrong. With concavity, if you include it, then it is wrong because you can't be concave or up or down at the point of inflection. So to me, the easiest way for y'all to remember it, not get things, if we're increasing or decreasing or we're talking about concavity, just leave them all open and don't overthink it because it does get confusing. All right, good question. What else you got? All right, so then I want to know when H is increasing. So am I going to look for when F is increasing? No, because there's a reflection, right? And it's because of that reflection, I have to think about it. I actually need to know when F is what? Decreasing. So F is decreasing, and write those intervals down. Figure out where F is decreasing. Check yourself with me. Melvin, you agree? Hard to agree when you're asleep. Sit up. Everybody good with where F is decreasing? We should be able to figure out increasing and decreasing by now, hopefully, right? And then we can say, therefore, H is increasing, which is what we really want, on, and then what do I have to do with all these numbers? Subtract 3, exactly. So -8 to -7. -4 to -2, and 1 to 2. What questions do we have? Anything? Okay. So this last part is very similar to the front where it asks you how many times g of x equals 0. Here it's just saying find any solution. So we want the actual solutions now for when h of x equals 5. All right, so we know h of x is -2 times f of x plus 3 minus 1, right? That's what they gave me for h. And I'm going to set that equal to 5. We're going to look at this one 2 different ways because I think the first way is easier, but it's a little harder sometimes for people to wrap their minds around. I want you to remember when we go to solve this, that this right here just represents some y value. So I'm just going to treat it like one big variable. I'm just going to do everything around it. So I'm going to add 1 to both sides. So I get -2 times f of x plus 3 equals 6. Then this is being multiplied by this big variable here. So I'm going to divide both sides by a -2. Get f of x plus 3 equals -3. Because remember, I've got this 2 is just like -2 is stuck to that. So that represents multiplication. This does not represent multiplication. I'm not multiplying f times the quantity of x plus 3, right? That means something completely different. All right, so here's what I want you to make sure you understand. This whole thing here represents some y value because f of x represents y, yes? This inside of here represents some x value because I take some x value, I put it into my function, and I get a y value out. You with me on that? So this is saying there is a y value that equals -3. And I want to figure out what is the x value when y equals -3 for f. So I go up here. When y is -3, here's -3, there's only one time where in my function where y is -3. That happens when x is -4. You with me on that? So now, right now I have y equals y. Y equals y. I'm going to take this x value, which is x plus 3, and I'm going to set it equal to the x value where the y value is -3, which is -4. Then to figure out what the x value is, where h of x, it's like trying to actually get this x value out, I subtract 3 from both sides, and x equals -7. Now, this whole pulling it off the graph and this jumping out of here, sometimes that's a little hard for people to wrap their minds around. So I'm going to show you a different way that I don't know is, that much easier to comprehend, but maybe it just, everybody's brain works differently. So we can look at it both ways. You decide what you like better. So if I have this ordered pair x, y, I know that that transformed to x minus 3 and -2y minus 1, right? We can think about it in our ordered pairs. You'll see as I take you through this, you're doing the exact same math, but if it makes more sense for you to do it this way, it's fine. So what this is saying, so remember this is f and this is h. So h of x equals 5. That means the y value for h is 5. So if I put 5 in here. Well, if I know that this is 5, I can use these two things having to be the same, because that's where the h is, to figure out what this y value actually is. So if I have a little equation here, I can set up -2y minus 1 equals 5. I can add 1 to both sides, -2y equals 6. So y equals a -3. So -3. Basically, we're going backwards. So you can see if I took this y value, multiplied it by a -2, and subtracted 1, boom, that's where I get the 5 from. Okay, so that's all fine and great. But then I need to figure out what these x values are. Well, this comes from f. And when I go up to my graph, when y is -3, the x value is -4. So I know for f specifically, I have the ordered pair -4, -3. Then to figure out what this x value is, I just take -4, subtract 3, and I get -7. It's the exact same pieces, it's just however you want to reason through figuring it out, basically. Sometimes this kind of thing makes more sense to people, but whatever works for you, I'm good with. Okay. What questions you got? All right, so I'm going to give you your assignment for today. All of the keys are over there in the book, so make good use of your time to work together on this.